Hello everyone, I'm Shachin. Today I'm going to talk on the topic of wrestling from future to the past, the transition to parallel computing. Well, coming to the start, introduction to parallel computing. Parallel computing involves executing multiple processes simultaneously to improve performance. It represents a significant evolution of traditional serial computing methods. Transition has been driven to increasingly demand for processing power and efficiency. So how this works is by this parallel computing process. It helps in executing multiple processes at the same simultaneous time to improve performance. Like multiple processes run at the same time at the same place to improve the performance drastically. It represents significant evolution from transitional computing which is done at a singular task is done at a singular time from being done multiple tasks at a singular time. So this transition has been driven, which this is this transition has been taken place because of the increasing demand for processing power and efficiency. Well, coming to the historical context of computing, early computers used to rely on sequential processing, which is to handle like one task at a time. Limitations of serial processing become apparent with complex data-heavy applications. The need for faster computation led to development of parallel processing architectures. So, if we talk about how computing was before, earlier computers at the start used it to at the beginning of computing, the process was used to then like a singular process was been divided into multiple parts which every single part is done at a singular time. But with it being updated, a singular entire task is being done at a singular time. And now, due to this parallel computing, a multiple amount of tasks are running at a parallel time, and at equivalent time. Parallel tasks are being run. So the limitations of serial computing, due to the lack of processing power, etc., became apparent with complex and heavier applications due to development. The need for faster computation led to development of parallel computation. So the need to process these complex, heavy applications uh, made rise to this development of parallel processing architecture. Well, coming to evolution of computing architectures, from vacuum tubes to integrated circuits, hardware advancements enabled more complex designs. The transition from single core to multiple processors marked a pivotal shift. Modern architectures now incorporate hundreds or thousands of cores of parallel execution. So this evolution of parallel computing, it didn't only came with the uh, up, uh, improvement of software but also the hardware too. Uh, from the transistors to from the vacuum tubes, the beginning of the computer hardware, when they are upgraded to integrated circuits and then to transistors, and now the CPUs, etc. The hardware advancements being made improved also helped us to use a more applications and to create something more with more which takes more amount of storage and more amount of processing power to create many new things, many complex things due to this improvement of hardware. Like the quantum computers which exists are the latest technology in present now. They help us u- to utilize that amount of power. We also need to we also need to do this parallel computing. So the transition from single core to multi-core processors, these are also a great milestone in the hardware of the system. It also increased performance by a lot, and also made this it is also one of the pivotal reason for making this parallel computing possible. Now, the modern architecture and I mean the model provisions we have, like the modern CPUs, the processors, the processing units, different graphic processing units. Now, these incorporate hundreds of thousands of cores of different uh, hardware for parallel execution. So these hardware is also plays a large part in this parallel computing. Now, coming to key concepts in parallel computing, tasks are divided into small and independent units that can be processed concurrently. Synchronization and communication between processes are critical to maintain accuracy. Efficient algorithms and data structures are essential for optimizing parallel performance. So how the parallel computing process works is by it divides tasks into smaller independent units that can be processed concurrently. So these tasks, when they are divided, they can be done pretty fast. So if it singular task is divided into 100 divided different independent units, each task can be done comparatively fast and also takes less processing power due to the task being very much small. So this how the this is how the smaller tasks can be all processed at once. Instead of being a large complex task, they are divided into 100 small tasks, which is less burden for the computer itself. So this synchronization communication between these processes is critical to maintain accuracy, because if the 100 small tasks, if they have accuracy error, it may divide the one singular big task which you have, which these tasks are derived from. So the synchronization between every single one of these minimized tasks, these independent units of tasks, is very necessary. So the efficient algorithms and data structures are used to maintain, uh, optimize these divided tasks to achieve the proper accuracy and the performance, parallel performance. Well, coming to the types of parallel computing. Data parallelism focuses on distributing data across multiple processors for simultaneous processing. Task parallelism involves executing different tasks or functions in parallel. Hybrid approaches combine both data and task parallelism for complex applications. So there are two types of parallel computing. One is data parallelism, another is task parallelism. So this data parallelism focuses on distributing data across multiple processes. Like if your computer allows multiple processors, which can help in parallel processing. This data parallelism focuses on distributing data across multiple processors, which can enable us to the parallel computing. Like each single core have each processor handles uh, half of the data. If you have two processors, one handles half of the data, another handles another half of the data. So coming to task parallelism involves executing different tasks or functions in parallel. So like it runs two tasks at once. Two tasks, like in a singular in function, it runs two tasks. Well, the hybrid type of parallel computing, it combines both of these to for complex applications. For if one type of parallelism is not amicable or applicable for the data, distributing the data, these hybrid applications can combine both data and task parallelism for complex applications. Advantages of transition to parallel computing. Significant reductions in processing time enable faster data analysis and decision making. Improved research iteration leads to better scalability and energy efficiency. Parallel computing opens new possibilities in fields like scientific research, AI, and simulation. So this reduces the time taken to process the data required for data analysis. It also improves the resource utilization, like how the resource is utilized by the system, and also it opens new possibilities in the development of AI, and also helps in scientific research and simulation. Coming to challenges in parallel systems, in implementing these parallel systems, designing algorithms that effectively leverage multiple processes can be complex. Issues such as data synchronization, communication overhead, and load balancing pose difficulties. Hardware limitations and programming complexity require specialized skills and tools. So, designing these algorithms using multiple processors is a bit of a complex issue. There may be data synchronization issues, communication overhead issue, and load balancing difficulties too. So, the hardware limitations and programming complexity is require specialized skills and tools, like the system, the hardware talk which we talked about earlier, and the proper system is needed to resolve this complexity. Coming to the role of software on programming languages, languages like CUDA, OpenMP, and MPI facilitate development of parallel applications. Comparison and runtime systems help optimize code for specific hardware architectures. Continued innovation in software tools is essential to harness full potential of parallel computing. So the languages, like there are languages like CUDA, OpenMP, and MPI. These help in development of parallel computing. They are specifically made for parallel computing. So the comparison runtime systems which help the optimize the code of these languages, they are supported by specific hardware architectures which run just supported to this parallel computing. Uh, the continued innovation in software tools, like the development of the software, uh, this helps harness the potential of parallel computing. Well, coming to future trends and innovations, quantum computing and neuromorphic architectures are emerging paradigms complementing classical parallelism. Increasing integration of AI and machine learning accelerates development of smarter parallel systems. The ongoing miniaturization and networking of hardware will further enhance parallel processing capabilities. So, as we talked about earlier, the quantum computers and the quantum computing trend is now being very much increased, and these quantum computing emerging paradigms, this can help in easily complement implementing and complementing the this parallelism in the future very easily. The increasing integration of AI in this current systems, it is being il- uh, implemented almost in every device, any singular mobile phone, every singular smart device, etc. This accelerates the development of this parallel system. The ongoing the hardware being minimized as much as possible uh, is also gonna help us uh, make us enhance this processing capabilities by making a small amount of systems compile gathering being gathered at a singular point, which may give us a huge amount of processing power, which may help in this parallel computing. Coming to the conclusion, transition parallel computing is a continuation of harnessing the parts innovation for future progress. Embracing these technologies will be crucial for addressing the computational challenges ahead. A journey from the wrestling the part to shaping the future underscores the dynamic evolution of computing technology. So the until now the development in being done about this parallel computing, it's been made from errors many errors, like like creating something new, like the computing process itself is something which was being done in the recent 100 years, and it being developed over 100 years, like day by day, error by error. The transition from parallel computing to the normal computing is our past efforts being recognized now, and it being computed. They paved the path for us. By embracing the technologies, it will be crucial for our development, also computer challenges which may come to us ahead due to the complexities which we arise. And also wrestling to the future to power shaping the future. This underscores the dynamic evolution we are being which are being undergoing through, and also represents our development as a as a race itself. Thank you for listening to the presentation.